Dear learners, in this video we will delve into the fascinating world of audio fundamentals, microphones and audio amplifiers. Understanding these core concepts is essential for creating an immersive audio experience in your home. So let's embark on this journey to explore the building blocks of audio technology. So audio is an integral part of our daily lives, from enjoying music and movies to engaging in virtual meetings and conferences. To truly appreciate and harness the power of audio, it is crucial to grasp the fundamental principles that govern sound waves, frequency, and amplitude. This knowledge empowers you to make informed decisions when setting up and optimizing your domestic audio systems. In this video, we will delve into the heart of audio technology. First, we will be exploring the nature of sound waves and their properties. Next, we will be unraveling the mechanics behind the various types of microphones and their applications. And then, we will be demystifying audio amplifiers and their role in enhancing sound quality. By the end of this video, you will have a solid foundation in audio concepts, enabling you to make informed choices and building your own domestic audio setup. So without further ado, let's kick things off by delving into the intriguing world of sound waves and audio fundamentals. To truly comprehend the magic of audio, we must begin with the essence of sound itself. Sound wave. Sound waves are vibrations that travel through a medium, typically air, and stimulate our ears, allowing us to perceive sound. So let's explore the key components of sound waves. The first one is frequency, the number of cycles a wave completes in 1 second, measured in hertz. Higher frequencies result in higher pitch sounds, while lower frequencies produce lower pitch sounds. The human range of hearing span is from 20 Hz to 20,000 Hz. Second one is the amplitude. The strength or intensity of a sound wave is usually measured in decibels. Greater amplitude corresponds to louder sounds, while lower amplitude produces quieter sounds. Third one is wavelength. The physical length of one complete cycle of a wave related to frequency. Higher frequency have shorter wavelengths and vice versa. Now we come to human hearing range. Our ears are sensitive to a wide range of frequencies, allowing us to enjoy a diverse array of sounds, from the deep bass to sparkling treble. This auditory range is essential when designing audio system to ensure that no nuances are lost. Now we come to importance of frequency response. When selecting audio components, particularly speakers and headphones, critical factor to consider is frequency response. This metric indicates how well a device reproduces different frequencies with the audible range. A flat frequency response ensures faithful sound reproduction, while deviations can lead to imbalanced audio. By understanding these audio fundamentals, you will be better equipped to optimize your domestic audio systems for a rich and accurate sonic experience. Now that we have grasped the basics of sound waves, let's move on to explore the captive realm of microphones and their role in capturing sound. Microphones are the gateway to the world of sound, transforming intricate vibrations into electrical signals that can be processed, amplified, and ultimately heard. Let's uncover the mechanics behind their remarkable process. Generally, a typical microphone consists of a diaphragm, which is a sensitive element that moves in response to sound waves. As the diaphragm vibrates, it generates variations in electrical signal, mimicking the original sound. Now we come to the different types of microphone. The first one is dynamic microphone. They are rugged and versatile. These microphones are commonly used on stage and for recording instruments. They work by using diaphragm attached to a coil with a magnetic field, generating an electrical current. In the context of dynamic microphones, an integral setup involves the utilization of both a permanent magnet and a coil. The amalgamation effectively facilitates the transformation of sound vibration into corresponding electrical signals. The second one is condenser microphones. offering exceptional sensitivity and detail. Condenser microphones utilize an electrostatic diaphragm and requires an external power source for operation. When considering a condenser microphone, its construction involves the presence of a backplate and a resistor. Unlike dynamic microphones, condenser microphones require an external power source to facilitate their operation effectively. This power source is necessary to maintain the voltage across the microphone's components, enabling it to capture and transmit audio signals with enhanced sensitivity and accuracy. The last one is ribbon microphone, known for the vintage charm and warm sound. Ribbon microphones employ a thin metal ribbon suspended in a magnetic field, translating air movement into electrical signals. The construction of a ribbon microphone follows a straightforward design principle. It involves the placement of a corrugated aluminum strip positioned delicately between the two permanent magnets. This configuration plays a pivotal role as it enables the effective capture of audio signals with precision and fineness. Now we will discuss about polar patterns. Directing sensitivity microphones exhibit different polar patterns which determine their sensitivity to sound from various directions. Three common patterns are omnidirectional. In this case, it captures sounds equally from all directions. Next comes the cardioid. It is more sensitive to sound from the front, less sensitive to the sides, and minimally response from the rear. Last one is bidirectional. Picks up sound from the front and back, rejecting sound from the sides. Now come to applications of different microphone types. Matching microphone type to application is crucial for achieving optimal results. Dynamic microphones are mainly used for live performances and loud instruments. Condenser microphones are used for studio recording, capturing intricate details, and ribbon microphones are used for vocals, acoustic instruments, vintage style recording, etc. Understanding microphone types and polar patterns empowers you to make informed choice when selecting the right microphone for the specific recording needs. With this grasp of microphone fundamentals, let's proceed to explore the technical specifications that help us choose the perfect microphone for our audio endeavors. Choosing the perfect match, selecting the ideal microphone involves considering various technical specifications that define its performance and capabilities. Let's delve into these specifications to make informed decisions. The first one is sensitivity. It is measured in millivolts per Pascal. Sensitivity indicates how responsive a microphone is to sound. Higher sensitivity captures quieter sounds, while lower sensitivity is suitable for loud sources. The second one is SPL handling. Sound pressure level. Handling refers to a microphone's ability to withstand high sound pressure levels without distortion. It's essential for recording loud instruments or vocals. The third one is frequency response chart, a graphical representation of a microphone's output across different frequencies. A flat response indicates accurate sound reproduction, while variations create a unique sonic signature. The fourth one is signal to noise ratio or SNR. Signal to noise ratio quantifies the level of desired sound compared to background noise. A higher SNR indicates better noise performance. The fifth one is impedance. The impedance measures the opposition to an alternating current. Matching microphone impedance with equipments, mixer, preamps ensures optimal signal transfer. Now, understanding these specifications empowers you to select a microphone that suits your recording environment and application. For instance, a sensitive condenser microphone with a wide frequency response might be ideal for capturing a delicate vocal nuance in a controlled studio settings. Remember, each specification contributes to microphone's overall performance, making it a versatile tool in your audio environment. As we have covered the intricacies of the microphone, we are now equipped with the knowledge to embark on our exploration of audio amplifiers, the powerhouse behind turning these captured signals to an amplified, immersive auditory experience. Selecting the optimal microphone involves aligning its characteristics with the specific recording situation and desired sounding qualities. Let's explore how to make the best choice. Consider the recording environment. Studio settings. In control environment, condenser microphones capture nuanced vocals and instruments with exceptional detail. Live performance, dynamic microphones excel due to their durability, resistance to feedback, and ability to handle high sound pressure levels. And for vocal, a condenser microphone with a cardioid pattern captures vocals very effectively. And for instrument, different instruments may require specific microphones. Dynamic mics for drums, ribbon mics for strings. Quality microphones come in various price ranges. Balance your budget with the desired sound quality and application. Now let us discuss some example scenarios. Recording a podcast. Choose a cardioid condenser microphone for a clear vocal capture and minimal room noise. For a live music performance, opt for dynamic microphone to reduce ambient noise and minimize feedback. Selecting the right microphone enhances your recordings and ensures that final audio output matches your creative vision. Now that we have explored the world of microphones and sound capture, let's shift our focus to the powers that brings these capture signals to life, the audio amplifiers. Audio amplifiers serves as the backbone of any audio system, taking with electrical signals from microphones and other sources and boosting them to the level suitable for driving speakers. This amplification is essential for delivering clear and powerful sound. Now let us discuss about the components of an audio amplifier. In the input stage, it amplifies the weak input signals. Next comes the gain control. It adjusts the amplification level. Then the tone control, it fine-tunes bass, mid-range and treble frequencies. And in the stage of power amplification is boost the signal to drive the speakers. And in output stage, it connects to the output speakers. Let us discuss some classes of amplifiers. Amplifiers are classified based on their circuit design and efficiency. Their common classes are Class A. It offers high quality sound but is less energy efficient. Class AB. It balances between quality and efficiency, suitable for most audio applications. And Class D. It is highly efficient with minimal heat generation and ideal for portable devices. Amplifiers are rated by their power output, usually in watts. Higher wattage generally means louder sound. Efficiency is a measure of how effectively an amplifier converts electrical power into sound, influencing energy consumption and heat generation. As we delve deeper into the world of audio amplifiers, it is essential to explore a phenomenon that can affect sound quality, distortion and clipping. Now let us discuss these different causes and types of distortion. Distortion occurs when an amplifier output signal deviates from the input signals, leading to a altered sound characteristics. There are several types of distortion, including harmonic distortion. It adds harmonics that they were not present in the original signal. Intermodulation distortion. In this case, it creates a new frequencies due to the interaction between multiple frequencies in the input. And then we come to the clipping. Clipping is a severe form of distortion that occurs when an amplifier output voltage exceeds its maximum capacity. This results in the clipping of the waveform, leading to a harsh, distorted sound. Importance of headroom. Headroom refers to a space between the highest undistorted level a system can handle and the maximum output level. Providing ample headroom prevents clipping and ensures clean, undistorted sound production. To prevent distortion and clipping, use proper gain staging. Set appropriate gain levels at each stage of your audio signal chain. Monitor signal levels. Keep an eye on input and output levels to avoid overloading the amplifier. Use limiting. Incorporate limiters to control the signal peaks and preventing clipping. Now, by understanding distortion, clipping, and the significance of headroom, you can maintain the integrity of audio signal and deliver a high quality listening experience. As we delve deeper into the audio amplifiers, let's explore the crucial specifications that define an amplifier performance and guide your selection process. The first one is wattage and RMS power. Wattage indicates an amplifier's power output. Higher wattage generally means louder sound, but quality matters too. The next one is root mean square or RMS. Reflects the continuous power an amplifier can deliver without distortion. It is more accurate indicator of real load performance than peak power. And total harmonic distortion measures the level of distortion introduced by the amplifier, Lower the THD values indicates cleaner, more accurate and sound reproduction. And the final one is, and it is most important also, signal to noise ratio. SNR quantifies the ratio of desired sound to unwanted noise. A higher SNR ensures a clearer audio signal and minimize audible noise. Next we come to impedance matching. Matching amplifier impedance with your speaker ensures efficient power transfer to optimal sound quality. Mismatched impedance can lead to poor performance or even damage. While selecting an amplifier, consider the interplay of these specifications to match your audio system's need. For example, if you are setting up a home theater, an amplifier with ample RMS power and low THD would be a wise choice. By understanding amplifier specifications, you can make well-informed decisions to create a harmonious and high-quality audio experience. Now that we have explored the intricate details of audio components, let us harmonize our understanding by delving into the concept of seamless audio system integration. This process unifies microphone, amplifiers and speakers to create an immersive and impeccable sound experience. First, creating stable connection. Balance versus unbalance. Prioritize balanced connections to minimize interference and mental signal integrity, particularly over extended distances. Cables and connectors. Utilize appropriate cables such as XLR or TRS for balanced connections, ensuring a clean and noise-free signal transfer. Preamplifiers and mixers. Employ preamplifiers to boost the weak microphone signals and mixers to adjust and blend the multiple audio sources. Now we can finally discuss the flow of audio signals. First one is microphone input. It captures the sound and forward it to the preamplifier. Preamplifier amplifies the microphone signals to usable level, and mixer, which is optional, enables control and blending of various audio input. Then comes the amplifier, increases the signal strength to drive the speakers, and final one is the speaker output. It converts amplified signal back to audible sound waves. By mastering this signal flow and embracing balanced connections, you ensure an uninterrupted and clear sonic journey. As we conclude this segment of our presentation, we excited to provide you with a glimpse of enriching topics that awaits in part 2 of our domestic audio system series. In the next video, we'll discuss about the speakers to installation process. We'll delve into the step-by-step process of installing speakers in various environments, explore placement strategies for optimal sound dispersion and acoustic enhancement, learn about different types of speakers and their ideal applications, and we will also discuss about electrical requirements of audio systems and troubleshooting procedures, where you will equip yourself with essential techniques to identify and address common audio issues, learn how to diagnose problems with microphones, amplifiers, speakers and connections, understand when to seek professional assistance and when to troubleshoot independently. With part 2, we aim to empower you with comprehensive knowledge to create, optimize and troubleshoot your domestic audio system effectively. As we draw our audio system part 1 video lecture to a close, let's reflect on the key takeaways from the exploration of audio fundamentals, microphones and audio amplifiers. Sound waves are foundation of audio defined by frequency, amplitude and wavelength. Microphones convert sound waves into electrical signals through diaphragm vibrations. Different microphone types and polar patterns cater to various recording scenarios. Amplifier empowers us to amplify and enhance audio signals for powerful sound. Specifications like wattage, THD, SNR and impedance guide amplifier selection. Audio system integration involves balanced connections and optimal signal flow. Now let us discuss some questions related to the topics that we have covered till now. Now, thank you for joining us on the enlightening audio journey. We eagerly anticipate reuniting in the part 2 as we continue our exploration of the captivating world of domestic audio. Until then, keep your curiosity alive and your passion for sound thriving.